And finally, our last two examples. Hopefully it makes sense already, but just in case, we'll do two more. All right, in December 2002, Consumer Reports reported a study on the presence of bacteria in packages of chicken sold in supermarkets. Are consumers safer buying the name brand chicken? So we're going to say name brand is Tyson and Purdue is the store brand. So we're going to go ahead and look at the null, which is that they're both equally contaminated. That's a lot of contamination, by the way. And our alternate hypothesis is that the Tyson proportion of contamination is less than Purdue, which, by the way, considering this proportion is higher, we could probably almost say, oh, you almost don't need to run it, but we're going to go ahead and run our hypothesis test. And then I also wrote my alternate in this alternate form. Remember to define what your proportions are. In this case, a brand name chicken is Tyson with the T there, and Purdue, that should be a P, but it says a D. All right, and then I'm going to do a 2-sample z-test for P, and we already checked our conditions in the previous video. All right, so our point estimate is the difference in proportions, and I have 0.56 minus 0.33, which is 0.23. My pooled proportion, when I combine both samples, gives me 447. So we go ahead and calculate the standard deviation using the pooled proportion here on top, and the two sample sizes are the same, so the denominators look the same, and I get 0.0812. Calculate my z-score. Remember, that's the difference, not the pooled proportion, over the standard deviation. I get 2.83. And I want the Purdue packages to the proportion to be lower than this, so I'm actually looking for this area. And I get a huge p-value of 0.9977, which was kind of my point. We almost don't have to run the test. But we'll go ahead and do our conclusions. With a p-value of 0.9977, which is greater than alpha of 0.05, we fail to reject the null hypothesis. There's not enough evidence that the name brand chicken is safer than the store-bought chicken. All right. And now our last example, we're looking at boys and girls who listen to music in high volume. So they've got these Dutch boys and girls, 397 boys out of 764 did listen at high volume, 331 out of 748 girls did listen at high volume. And they want to do the sample data support the author's conclusion that the proportion of Dutch boys who listen to music at high volume is greater than the proportion of Dutch girls. And we're going to use a 0.01 significance level instead of the 0.05. They gave it to you in the problem. So here's my null hypothesis, is that there is no difference. And where PG is the true proportion of girls and PB is the true proportion of boys who listen at high volumes. My alternate is that boys is higher than girls, so this difference would be greater than 0. My plan, well, it's a 2-sample z-test for P. Random, I've got to assume it. I don't have any information, so I'm going to say need to assume that it was random or at least a representative sample. The 10% condition is fine. I promise you there are more than 7,000 boys in the Netherlands. And the large, and girls as well. The large counts, I went ahead and counted the number of high volume girls and not high volume girls, and the number of high volume boys and not high volume boys, and they're all fine. So let's go ahead and do our point estimate, which is difference. And I get a difference of about 7%, 0.0771. Then I do my pooled proportion, and I get a proportion of 0.481. So on average, if I put all the boys and girls together, 48% listen at a high volume. Now we'll go ahead and calculate the standard deviation using that pooled proportion, and notice the different sample sizes here, and I get 0.0257. Take my point estimate, which is 0.0771 minus 0 over 0.0257, and I get 3. So my p-value, let's see, 3 is way over here. If I do normal CDF of 3 to 1,000, I get 0.0013, which leads to the conclusion that with a p-value of 0.0013, which is less than the alpha they told us, 0.01, we still reject the null hypothesis that the true proportion of boys and girls who listen to music at high volumes are the same. There is convincing evidence that the proportion of boys who listen to music at high volume is higher than the proportion of girls who listen to music at high volume.